Good morning, students. This is your Koppal sir. Welcome to Gurukula tutorials. So today we are discussing about the stress analysis by using of Ansys Workbench. So here I take on simple problems. Now I read the problems. A line shaft running at 200 RPM. Here is given the speed. It should be in RPM only. Is to transmit 20 kilowatt. Here the power is given 20 kilowatt. Here power should be in kilowatt only. The shaft may be assumed to be made up of mild steel with an allowable shear stress of 42 megapascal. He is given the shear stress, that is tau. The value of tau is 42 megapascal. You have to convert this in the Newton per mm square. If you convert, the 42 megapascal is same only, that is 42 Newton per mm square. The length of shaft is 300 mm. Here is given the L, it is 300 mm. Calculate the diameter of the shaft and evaluate the stresses by using of Ansys Workbench. So here we are using from data handbook, take the equation by finding of torque, that is T is equal to 9.55 into 10 to the power of 6 into P divided by N. From this equation we have to find out the torque. So after that we have to find out the diameter of the shaft by using the equation from the data handbook. Tau is equal to 16T divided by pi d cube, where d cube you have to find out the diameter of the shaft, that we get 48.75 mm. From data handbook, just select the standard diameter of the shaft from table in the data handbook. It is 50 mm. That means the diameter of the shaft is 50 mm. So this is your calculations is over. After calculating the diameter of the shaft, just analyze the stresses. So that stresses should be, here it is the shear stress is 42 megapascals. When you analyze the stresses from Ansys Workbench, it should be within 42 megapascal. Just open Ansys Workbench, double click. So then select the geometry and double click. Then select millimeter, then OK. So after that, here there is a extrude command. Select extrude command. So after that select generate. So then here there is a sketching in left side of your screen. Select sketching. After that select circle. Once you select the circle, select the direction. Here you see in the right corner of your PC, it is blue color, that is Z direction. Select Z direction. From the center, just you draw one circle. After draw the circle, you select dimensions. It is in sketching. Modify, below the modifier there will be dimensions. Select dimensions. After that select diameter. Then select the circle. The color will be changed. Once again select the circle. Here there will be a table is comes, that is D1. It is 25.016 mm. What you draw, just modify this as 50 mm, because from the calculations your diameter is 50 mm. So once you enter the 50 mm, then enter and then generate. So after generating, go to modeling. It is near to sketching icon. So from modeling, in the left corner of your PC there will be extrude 1. From extrude 1 select right click, then edit selection. After that here there will be a table, apply. Once you apply, below the table there will be a FD1, that is depth of the shaft. The depth means length of the shaft. Here the length of the shaft is 30 mm. So click on 30 mm, enter the length of shaft. Here the length of shaft is 300 mm. So double click the 30, enter 300, then enter. After entering, select generate. Once you select the generate, your icon color will be become dark or gray color. So keep this shaft in isometric view. From the right side corner of your PC, so here there will be a blue dot on small ball. So when you go to cursor, it will show ISO, that means isometric view. Select one, so your project will become in the isometric view. Once complete all these things, just from the left side of your PC, at the top of the PC there will be a project. Select the project. So then new simulation, it is just below the open icon. select a new simulation. Once you select the new simulation, what you draw in the previous page, it will appear in the screen. So after that, you go to mesh, right click on mesh, preview mesh. For analyzing the stresses, your shaft design will be changed. After inserting the meshes, just go to environment. It is also just below the mesh, right click, insert. After that, so just select the fixed support. So here there will be two supports, one is left of your shaft and right of your shaft. For easy analyzing the stresses, just select left side as a supportive. So the color will be changes, then apply. Here geometry, apply the geometry. So the one end is fixed. After that, again go to environment, right click, insert. In that insert, select the movement. Once you select the movement, select the shaft, apply. So when you apply, then you go to the torque. Just you have to apply the load. Here there will be a magnitude. It is shown in the yellow color. Here the magnitude is 0 and the unit is Newton meter. But in our calculations, here the torque is Newton mm. So this torque is converted into Newton meter by dividing the 1000. So it will become 955 Newton meter. Just double click on enter 955, then enter. So once you enter, here there will be one command is appear. Below the magnitude there will be a click to change. Select the click to change. Always our load should be towards the fixed end. Here it is in the reverse position. Just select towards the fixed position and then apply. So you applied the load, then go to solution. So in this solution, what you need, just go to solution, go to insert. From the inserts, the second icon is stresses. From this you can select the which one values you want, that just select. Here I select equivalent one minus stresses. You can also select the strains. Now I need the stress. I select stress, and under that I select equivalent one minus stress. Again go to solution, right click, then solve. So now your problem is solved. Just select equivalent stress. So your stress is appear. Here the stress, maximum stress is 9.5 into 10 to the power of 7. That means 7.5 Pascal. 7.5 Pascal, and the minimum stress is 1.15 Pascal here. But what we have, it is 42 megapascal. That means the stresses induced in the shaft is within the limit. So you can also animate the how the stresses is shown in the shaft. Just you go to animation and then you right click on the graph. Here there will be a play. Just play it. So it shows the how the stresses is induced in the shaft. Again right click, stop. If you need the report, just go to print preview. It will get the report of one minus stresses, right? So this is how the stresses can be analyzed by using of Ansys Workbench. Thank you for watching and keep watching.